Good afternoon, everybody. It's just about afternoon now. Welcome to you all. Welcome to this Cambridge Festival 2022 session. We're delighted to see everybody. My name is Liz Woodham. I'm a member of the NRICH team. We're based here in Cambridge. I'm not going to be leading very much of this webinar. I'm going to leave you in the very capable hands of Claire and Charlie, who are here too. Just before we get going properly, we wanted to let you know that we will be asking you at various points to contribute using the chat facility, but when we're not asking you to contribute, we'll close it off so that you won't be able to use it. If at any stage you have a concern, then do feel free to email us at events@maths.org. I'll just pop that email address into the chat in 1 second. But we're really happy that you're here on this Saturday afternoon. So what we're going to do is we're going to introduce you to some of our favourite NRICH tasks, all freely available on the NRICH website. We've collected links to them all onto our Cambridge Festival page. We'll give you the URL for that at the end so that you'll be able to explore further. I'm not going to say any more. I'm going to pass over now to Claire and Charlie. Thanks, Claire. Thanks, Charlie.
Thanks, Liz. So I'm going to introduce Claire to some of the problems, and to do that I'm going to need to share my screen. And Claire, can you see a problem called fruity totals?
I can, yes.
Okay. And as Liz said, we will be sharing the links to all the problems that we introduced today. And the idea is to give you a flavour for what the problem is, and then hopefully after today, most of you are on Easter holidays, you'll return to these problems and think more deeply about them. Okay, so Claire, here we have an interactivity. You're told that each fruit has a value between 1 and 15 inclusive. The sum of the values of the fruit in each row and column are shown. So for example, this apple plus this plum, or it might be a damson, banana and another apple add up to 25, and likewise the banana, the cherries. The only reason I think it might be damsons is because apples start with A, bananas start with B, cherries start with C, so I'm assuming it was D for damsons. But
yeah, so we haven't got donuts because we're trying to go for a healthy eating lifestyle here. Yeah.
And so the question is, can you work out the value of each individual fruit?
Okay. Well, I've got a lot of bits of information here. I think I've probably got too many bits of information to deal with all at once. So I think I'm going to look at this top row to begin with. So can you see the one that I've circled?
Yeah, yes, I can.
Yeah. And I also think my drawing skills are not the best. So I think I'm going to summarize this one by saying 2A for apples plus 2B for bananas equals 34. So I'm using A to represent 1 apple and B to represent 1 banana. Nope, I think I've just lost the very edge of that off the side. I'll rewrite that again. There we go. Okay, so I just said that 2A plus 2B equal 34. Okay, I think I can therefore deduce that 1 apple plus 1 banana equals 17. Does that make sense?
Yes.
Okay, so that worked quite well. Let's have a look at the next column, not column, row. Here I've got 2 bananas and 2 cherries. And that gives me 32. And a similar way to what I did before, I can say, okay, so 1 banana plus 1, well, bunch of cherries is 16. Okay, what can I deduce now? Okay, I think this means that I've got 1 apple plus 1 banana is 17, and 1 banana plus 1 cherry is 16. I think an apple is one more than a cherry.
Claire, I thought that what you did initially was really useful and gives me your first equation where you got apple and banana 17.
Mm-hmm. So where else could I use that? Do we know anything else about
Okay,
these? Yep.
look at the first column.
Okay,
If you know that apple and banana 17, then
yep.
the beginning of your first
yes.
column has got an apple and a banana. So that must be 17. So the remainder of that column must be 8, because
yes.
the whole thing adds up to 25.
Okay, so I know that one apple plus a damson is 8. I think I can see now something else I can use. So this last one, I've got 1 apple and 3 damsons.
But you know that the apple and the damson is 28 already.
Yep. So that means that these two, this is getting quite messy. It knows that these two add up to 8. So these two must add up to 4, if my maths is correct.
It is.
So I know that 2 damsons are 4. So 1 damson is 2. Okay, I'm going to write this down the side here so I don't lose it. So 1 damson is 2.
And if you now go up a row.
Oh, hang on, before I go up a row, I think I've got this over here, this deduction.
Yes.
So if I know, shall we ask people in the chat to help us finish this off?
Okay.
Yep. So I'll just make sure the chat is open. So can you in the chat suggest what the other values must be? So you should be able to use it now. Oh, no. Okay, try again now. Oh, I've got lots of people saying that A is 6. Okay, so I think I agree with that because 6 plus 2 equals 8.
And then they've also worked out that banana is 11.
The banana one. Okay, so banana is 11. Let me check that. 6 plus 11 equals 17. Yep, I agree with that. And we have some C equals 5. So B plus C equals 16. 11 plus 5 equals 16. Yes, I agree with that as well. So I think we've done it.
We have.
Is it a good idea to check it? Should we check one more equation, or do you think we're fairly happy that that works?
I think what I'd like to do, I think there's possibly an easier way of doing this.
Oh, okay. So shall I clear what I've done?
Not everything, please. Can you clear everything on the chart, but leave your equations, the first 2 equations that you wrote on the right hand?
Probably easy if I just clear everything and then just rewrite.
Okay, well, it's okay.
Yeah.
Okay, so I'd like you to think about row 2, and a banana and cherry add up to 16.
Yeah.
Because 2 bananas and 2 cherries add up to 32. And now if you look at the final column, you've got a banana and a cherry at the top adding up to 16, the whole column adding up to 28. So the 2 apples must add up to 12.
Okay, so we've got this whole column. We know that a banana plus a cherry is 16. We know that everything adds up to 28. So we know that the sum of this is 12. Yes, and that is the same as 2 apples.
And so once we know, so the 1 apple must be 6, and then we can use that in the bottom row and figure out the rest, because then we'll have an apple and we'll have a damson, and then we'll be able to work out the bananas and so on. Okay, so I think we've sorted that one out, and it gives us the same solution. So when it comes to checking, it's quite nice to be able to do this in a different way. Mm-hmm. Okay, I've got, can we clear that screen?
Yep.
I've got a couple more arrangements of fruity totals for you to have a go at.
Okay.
What about this one? So
what about this one? Okay.
So what I'm trying to, so before you write anything, Claire, this time, I'd like you to see whether you can think ahead about what might be the most efficient strategy. What might be the easy, because you said there's more clues than we need. Are there any clues here that lead to the answer in the sort of the minimum number of moves?
Yeah, no, clues which have fewer than all four are quite nice, because then we're not looking at all four fruits at the same time. I think that this row, I'm not drawing on it, I think this last column looks quite useful. So I've got 2 apples and 2 damsons. So I can work out what 1 apple plus 1 damson is. And using a similar argument to the one they used last time, if I then know, oops, I was trying not to draw. If I then know what 1 apple and 1 damson is, I can use this row to work out what 2 bananas is. And I think that would be quite efficient. So then I've worked out what bananas is. Can I use that efficiently somewhere else?
Can I just check? You're using column, can we just, so column, I'm going to call this column 4 for, it maybe just, if you can just write C4 to represent, so let's not bother with the arithmetic anymore.
Yeah.
I'm just curious, so column 4 will give you some information about apples and damsons, which you're then going to use in row 4, is this right?
Yep.
And that's going to give you a solution for the bananas.
Yes.
And then once we know what bananas are, and we also know what.
Yes, I mean, I'm not quite sure where I would go next. I mean,
I think we can go to row 1 next, because once we know what an apple and damson are worth, and we know what a banana is worth, row 1.
Then we can work out what a cherry is. Yes.
And once we know what a cherry is, everything else is going to fall into place.
Yeah. The other thing I noticed about this one is we've got slightly less information than the last one, because the first row has got an apple, a banana, a cherry, and a damson, but so is the first column. So we've got one piece of information that's been given twice. And this row in this column is also
20s, and you've also got 2 11s, don't you?
2 11s, yeah, and it's the same fruit.
Second row.
So I think we have slightly less information.
Okay, so can we just annotate this? So I think we're saying C4, then R4 to represent row 4 would be the next one that we would be looking at.
4.
And that would tell us what the banana is. And then we'd go to row 1, because then we can use our information about the apple and the damson. We can use our information about the banana. Once we know what the cherries are worth and the bananas, we can then go to row 2, work out what the damson is.
Yes.
Good. Okay. And I mean, there's a little bit of arithmetic.
Okay, so we find what damson is, and then we should be able to finish it off.
Yes.
Yeah.
Okay. And we're not going to bother with the arithmetic.
Okay.
I think the important thing is we've got a strategy. It's not clear to me that it's necessarily the only strategy or that it's the best strategy, but when people come back to this problem, it might be quite a nice thing to be thinking about. I'm going to show you one more, Claire.
Yep.
And to do that, people can go to the cog here. And so far, we've been doing level 1 problems. I've got a level 2 problem already saved in my last tab here. And it's a level 2 problem because you don't get given the information either in a row or in a column.
Right.
There are, let me just go back here. There are level 3, level 4, level 5 problems. Let me just remind myself what a level 5 problem looks like. You can see you get given even less information on a level 5 problem. So when people get confident with level 1 problems, they might want to have a go at level 2 and harder problems. Okay, so here's the level 2 problem that I've set up for you, Claire. And again,
Okay.
can we?
Okay, so you've made, so it's slightly trickier. I think I would, because row 1 would give me that would give me an apple plus a damson.
Yes.
I'm not going to work out what it's equal to, but we've got 2 apples, 2 damsons, so I can work out what 1 apple and 1 damson is. Then I think I'd go to column 1, from which, since I know what an apple plus a damson is, I can work out a banana. Where would I go from there? I mean, I can then work out what this question mark is, if I wanted to. Actually, I could have worked that out beforehand. What should I? What would I do next? I'd go to column 2 next, because I know what 1 apple plus 1 damson is. So that would work out what an apple is. Now I know A and B. I would then probably go to row 3. I know A and B, so that would give me the damson, and then I would pick either column 4 or row 2. I don't think it matters which, to find out what the cherry is. Brilliant.
Okay.
And it'd have to be one of those 2, because those are the only places where cherry appears.
Okay. Okay. So this is the first problem, part of the reason we like it is that the kind of thinking that you were doing is very similar to the thinking that students are required to do when they work on simultaneous equations. There's combining, there's adding bits and subtracting bits and simplifying. So some teachers have said to us that they often do this, work on this exercise with students before doing work on simultaneous equations. And then when students come to working on simultaneous equations, they find that much, much easier than students who haven't sort of thought in this way.
It's also quite nice to try and find what's the fewest number of bits of information I need to use.
Yes, and
what's the
when
easiest
you get
way?
to levels 3, 4, and 5, it becomes harder. Okay, that's the first problem. We've had 15 minutes, and so I think I want to move on to a second problem for you now.
Okay.
It's called Charlie's Delightful Machine.
Right.
The way that it works is that I'm going to ask you to suggest some numbers here, just whole numbers. And the idea is to get the yellow light or the red light or the blue light or the green light to light up. But I'm also later on going to ask you to think about whether you can get more than 1 light to light up, or whether you can get, 3 lights or all lights. So if you just give me some numbers to start.
Okay, let's have 42, which is my favorite number.
Okay, so 42 hasn't lit anything up.
Okay, right, that's disappointing. Let's have 100.
Hasn't lit anything up.
Nothing up. Okay, let's have, what's a nice prime number? I think 83 is prime. I've got a red light. Can I put in a really big number?
Yes.
Let's try 1331.
Okay.
Oh, and the red light again. I don't think I'm learning very much by doing it like this. It's quite fun. I think I probably ought to do this in a slightly more systematic way.
I think that's a good idea. Did you notice anything about the first 2 numbers that you gave me, 42 and 100?
They were both even.
And the second 2 numbers
were both odd. So I wonder if red, whether it lights up when it's odd and not when it's even. So can I try 1? It's been okay. Can I try 2? Can I try 3? Can I try 4? And I'm just looking at the red one. Okay, so I think it looks like red turns on when it's odd and off when it's even. So I'll just try 2 more random ones. How about 37, which is odd?
I was going to ask you to make life easy for me by just, if I type in 41, 411.
Okay.
Or
Then let's put a 2 on the end. And it's off. Okay. I think it might be quite nice to be a bit more systematic about this. So we've already seen that with 1, 2, 3, 4, I can't remember if we went to 5, but red was on, off, on.
Okay, well, I'll go through them again. I wonder whether you should start again, Claire.
Yeah, I think we should start again with 1.
I think your writing needs to be just a little bit smaller, I'm afraid.
Oh dear.
Because I think you're going to want to go to.
I think I'm going to need to go quite big.
To at least 12.
Okay.
I'm glad you're doing this and not me. The writing is what I mean.
Yes. It can be quite hard to write small on a graphics tablet. 9,
yes.
10, 11, 12. Okay, well, let's keep our fingers crossed. It might be that we can. Yeah, okay, so 1. Off, on, off, off. Okay, 2. Okay, 2 is yellow on and the other 3 off.
Actually, you know what? You may be better just putting the ticks.
Okay, yeah, we'll do that.
The ticks will stand out more.
Yeah. Okay, so what's 3? Right, so 3 is, oops, red on, green on. Okay, so 4 is just blue on. And 5 is just red on. I've got a lot better at drawing straight lines in the past 2 years of using this. What's 6? 6 was nothing, was it?
Nothing.
Right, so red is 7, yep. 8 is yellow. 9 is red and blue. 10 is nothing. 11 is red and 12 is green. Okay.
I think you might have enough information to start making some conjectures or deductions here.
Okay. Well, I'm fairly happy.
Possibly have said these are all linear sequences.
Ah, right. Okay. So these are all linear sequences because I was going to make a conjecture about y being powers of 2, but that wouldn't have been very linear. Okay. So if they're all linear sequences, that means that the gap between the numbers that work will be the same each time. So for yellow, I've got a gap of 6 here. So if I just write on this side, yellow, we turn on 2 and 8. So if it's linear, that's add 6. So I think the next time it turns on will be at 14.
Do you want me to test that out?
Yes, please. And yellow is on. I'm just looking at yellow, so I'm going to ignore the blue.
Shall I add another 6?
Yeah, add another 6, which I think is 20. And it's on again. Okay. So I think I know what's happening with the yellows. We start at 2, then we add on a multiple of 6.
Okay.
Right, so let's try the blues.
Can I just check? One way that I like checking is by trying a really large number.
Okay.
So you said?
I said 2 plus a multiple of 6.
Okay, so can you give me a number bigger than 10,000 bigger than 1,000 that you think will like the yellow?
Well, let's have 6,002. I know that that's a multiple of 6 plus 2.
Good. And that's reassuring, isn't it?
Yeah.
Okay.
Okay, so let's look at blue. So blue at the moment turns on at 4 and 9. So in the chat.
Can I just check, why are you jumping to blue rather than to red?
Of course, I think we'd already worked out red. I thought
okay.
Yeah. So we think that red is every odd number.
Okay.
So blue.
Do you mind just making a note of it? Because
yes.
In a while, I'm going to ask you to think about getting. Thank you.
Yep.
Okay.
Okay. So in the chat for blue, can you suggest what the next number is that will turn it on? Okay, so we just want the next number. We don't want the sequence.
A lot of people are saying 14, so I'll check that out.
Yes, we have a blue light. And can you suggest the next one?
Everybody seems to be suggesting 19, and that works.
Perfect. Okay. So we think we know what's going on with blues. And then the last one.
Can anyone suggest a number bigger than 1,000 that'll turn the blue light on?
Okay, can I think of a really big number that I think will work? Or I like 9999.
Okay, so what most numbers have in common, but not all, is that the units digit is either 4 or 9.
Yeah.
But there are some numbers that don't have 4 or 9 as the units digit, and I'm not at all convinced that they would work.
Okay, so shall we try one with a 4 on the end? We've got 2022. That seems very relevant. Shall we try 2022?
Yeah, I don't think that's going to work.
No.
But somebody's got 1004, for example, which I think will work.
Yep.
And people had, there's a 2019.
Yep. And somebody said 69696969.
Why is it, Claire, that I'm so convinced that the numbers need to have a 4 or a 9 in the units column?
I think it's because it's, we've said that it's 4 more than a multiple of 9.
No, 4 more than a multiple of 5?
4 more than a multiple of 5, my mistake. So we said we're starting on 4 and then we're adding on 5 and adding on 10. So it is 4 more than a multiple of 5. But we could also think of it as being 1 less than a multiple of 5. So if we could put in the number at the start, a number before the sequence, we could have -1. And we could think of starting at -1 and adding on 5. Can we enter -1 as a number?
I don't think we're allowed.
We can't, no. But if we pretend we could, that would be the number that's 5 less.
Yes.
So I think we could also think of it as being 1 less than a multiple of 5. And I know that multiples of 5 end in either a 5 or a 0. So 1 less will end in either a 4 or a 9.
Okay, nice. Okay, so we now have a rule for yellow, a rule for blue, a rule for red. Do we have a rule for green yet?
Not yet. So green, I know it turns on at 9. Not 9. I know it turns on, I'm stuck on 9s now. I know it turns on at 3 and I know it turns on at 12. So in the chat, I was about to ask in the chat, but it's just been turned off again. But in the chat.
Sorry, somebody has said that I can put negative numbers by pressing on the minus sign. And here, just to confirm what you were saying, Claire, the -1 does light the blue.
Oh, perfect.
Okay, thank you.
Oh, that was nice. Check.
Thank you.
Okay, so we can do from 3 to 12, that's +9. So if I add 9 again, I think the next one's going to be 21.
Okay, let me try it out.
Okay, if I add 9 again, it's going to be 30. It's getting slightly messy.
Okay. So what's your rule here?
I think in this case, it's 3 more than a multiple of 9. So,
okay. So can we ask anyone to share in the chat a number bigger than 1,000 they think is going to work? Claire's rule is that it always seems to be 3 more than a multiple of 9.
Yeah, I do like the 9,003s. That's a nice one.
2003, that does indeed. But I'm also intrigued by some of the other ones. So 1,002, how do people know that that's 3 more than a multiple of 9? Well, it's 3 more than 999. Yep. 999 we know is a multiple of 9, and so 3 more. And then there's an 1,221. That hasn't lit the green light out on, so no. Then there's an 18,003. So
Okay.
18,000 is a multiple of 18, so it's also a multiple of 9. Nice. Okay, good.
Charlie,
okay,
can you just
Claire?
try one more for me? Can you try 184,565? Oh, I didn't. Well, I've done something wrong there. No, 66. Yay.
So some of you may want to think about, why does Claire expect 184,563 to be a multiple of 9? Because this is 3 more than a multiple of 9. Okay, Claire.
Yep.
I'm delighted you're rubbing all that out. I'm now going to give you a few challenges.
Okay.
So we've got the information there on the left.
Yep.
I'd like you to give me some numbers that are going to light the red and the blue light.
The red and blue lights, but not.
I don't mind if any of the others
Oh, you don't mind?
up,
Okay.
but I want red and blue to always come on.
Oh, well, I think 9 will work. Just from looking at, so I know that 9 is in the blues already, and I know that red goes 1, 3, 5, 7, 9.
Yes.
Do you want another number?
Yes, please.
Or
What's the next?
anything that will end in a 9.
Okay, how do you know this?
So I know for the blue numbers, they either end in a 4 or a 9. And I know for red, I need it to be odd. So I think the only way I can get an odd number that also ends in a 4 or 9 is anything that ends in a 9.
Okay, so I can type in a big number, and as long as it's got a 9 in the units column. Okay, yeah. Well, that was too easy. Okay, next challenge. I'd like a yellow and a red bulb to come on at the same time.
Yellow and a red. Ooh, I don't think I can do that. So for yellows, the pattern goes 2, 8, 14, 20, and I'm going to keep adding on 6s. And the yellow is 1, 3, 5, 7. So these ones are always even, and these ones are always odd. So I don't think I'm going to be able to do that.
Okay. Okay, what about a yellow and a green then?
Yellow and a green. Let's see if that's a bit easier. So 2, 8, 14, 20 are my yellows. And my greens are 3, 12, 21, 30. Okay, it looks like it's doable. Can you just
make a note that you're, so 2, 8, 14.
That was yellow.
Yeah, and the others are the green. Thank you.
Okay, so I need something that has to be 2 more than a multiple of 6, and also 3 more than a multiple of 9.
Can you make a note that that's what you're thinking about? Just, is there a quick and easy way of writing this?
Well, I'm going to write that one like this. So it's 2 more than a multiple of 6. So n could be 0, which will give me my first one. And G, I don't want to use an n again because I don't want to confuse myself, and call this 9 times k. Okay, I don't think this one is possible either.
I wouldn't give you 2 impossible ones in a row, would I, Claire?
Yeah, it's possible. I think this bottom one, I can write this as, well, I know that that bottom one is a multiple of 3. So this is a multiple of 3 because it's 9 times something. And this is a multiple of 3. So I would write this. You might not have seen this before, but I would rewrite it in that form. So it's 3 lots of 1 and 3 lots of 3k. So I know that bottom one is a multiple of 3. Whereas for the y.
And can I just check, even if you weren't used to doing that, you could think of G as 3 plus 3k plus 3k plus 3k. So multiple of, it's 3 plus a multiple of 3 plus a multiple of 3 plus a multiple of 3. It's going to give you a multiple of 3.
Yeah.
Okay.
Whereas this bottom one, I know that 6 is a multiple of 3. So I know that this bit is a multiple of 3. I've written times 3, I mean multiple of 3. So here I've got multiple of 3, but then I'm adding 2 to it. So that can't possibly be a multiple of 3.
So you're saying yellow and green never come on together?
I don't think yellow and green can ever come on together.
So if I do this very quickly, everyone can check. Does the yellow and the green light ever come on at the same time? So yellow comes on sometimes, but the green isn't on. And when the green comes on, the yellow one doesn't. When the yellow comes on, the green doesn't. Oh, did you see that? There were all 3 lights on. Well, before we do that, can you get the red and the green one to come on together?
Yes, on 3 would be the easy answer.
Okay. When will the next time that the red and the green come together?
21.
Okay. How did you know that?
Well, I looked at my list here of 3, 12, 21, and I know that red comes on for odd numbers. So that's the next odd number in my green list. If I hadn't had that written out, I'd know that if I take 3 and add 9, I'm going to get to an even number. But then when I add 9, I'm going to get to an odd number.
So you get to 21.
So I get to 21, yeah.
So if you add another 18,
Yep, it should work again.
you're going to get to 39.
Mm-hmm.
And if you add another 18, you get to 57. And so you can start predicting when the red and the green ones always come on.
Mm-hmm.
So they seem to be 3 more than multiples of 18. 3, 21.
Yeah, they are.
3 more than multiples of 18. So shall we try a really big number? This is a multiple of 18. And then I'm going to add another 3. Well, no, I'm not going to add another. I'm going to have a multiple of 18 plus
3. Yeah.
plus 3. So that seems to work. So the green lights came on every 9. The red lights came on every 2.
Mm-hmm.
The green and the red lights came on every 18. So it looks like there may be a connection here between the gaps between the numbers that the green lights come on and the gaps between the red ones. Okay, one last challenge then for you.
Okay.
We know that yellow is awkward because we can't get yellow and red to go on. We can't get yellow and green. But could we get red, blue, and green all to come on at the same time?
Well, we saw that happening, didn't we? So
we did.
We know it's possible. The question is, when is it possible?
So I'm asking for red, blue, and green.
Okay, so we know from what we've just done that red and green come on 3 more than a multiple of 18 from what we've done before. So that was at 3, 21, 39 and so on. Blue, we know that it comes on 4 more than a multiple of 5. So the red and green come on with gaps of every 18. Blue comes on with a gap of every 5. From what we've done, I think that red, blue, and green are going to come on together in such a way where the gaps are 90. So I've done 18 multiplied by 5 to get 90. So I think they'll come on with a gap of every 90.
Have you got a first number that we can try?
Yeah, that's the next issue, isn't it? So it's got to be an odd number. It's got to be 3 more than a multiple of 18, and it's got to be 4 more than a multiple of 5. I think 39. I think 39 will work.
And
That's
then you want me to add 90.
90. Yeah. So
So the
100
next one would be 129
129. Yep. And then
219. Oops, sorry.
No, yeah, 219. And then 309.
Well done. Okay. So in this particular setting, the rules, you've discovered all the rules, and you've discovered it's going to be impossible to have all 4 lights come on. For anybody wanting to try this interactivity out, you can click on level 1, which is what we've been doing, and then you're going to get a different rule. I mean, you can see 309 only lights the red ones up this time, and so every time we click on level 1, you're going to get another random setting, and it'll always be linear relationships. And the challenge is to try and work out rules for 2 lights coming on or 3 lights coming on. Sometimes it is possible to light all 4. But of course, if one of the rules only gives you even numbers, and the other rule, for example, gives you 1 more than a multiple of 4, and so you always get odd numbers, you won't be able to light all of them at the same time. For those students who are working with quadratic equations, you may want to try levels 2 and 3. So those are not linear relationships. And so you might want to do some plotting of graphs and the like. So that's a lot harder. But there's plenty to think about here. There's some follow-up questions in a little light thinking. Right, we've only got a couple more minutes left, Claire. So I just want to show a couple of other problems before we finish. And I'm showing these because they're sort of firm favorites of NRICH. So this one is our factors and multiples game. And in this one, we take it in turns to choose a number that is either a factor or a multiple of the number that came before. So for example, if I chose 40, you could then choose either a factor of 40 or a multiple of 40.
Oh, let's go for 8.
And then I can choose either a factor of 8 or a multiple of 8. So I'll choose, oh, you went for a factor. I'll also go for a factor. I'll go for 4.
Okay, I'll go for 100.
Okay, so you've chosen a multiple, and I'll go for a factor of 100. I'll go for 25.
Shall I keep going for a couple more?
Couple more.
I'll go for 75.
And that's a multiple of 3, so I'm going to go for 3.
Okay.
And we could carry on playing like this as a game, and at some stage one of us is going to get stuck because the basket of numbers available is going to go down, and we're going to find it difficult or impossible to find another number. So that's one possible way of playing this. Another one is to try and make the longest possible chain. So you and I could be working together on this rather than competing against each other. And so we could be going for, I don't know, 33, 99, 9,
72.
And keep going. Sorry, I can't see all my screen. There we are. But we might get stuck here and think, oh, I wish I'd put 40 in, but sorry, I've used 40. I wish I'd
80.
80 between 4 and 8. I can take the 80 and nudge the 4 out of the way and stick it in there. Let me show you again. Make it easier. I could put a number before the 40. So 20 is a factor of 40. So I can drag it. And likewise, I can put something in between the 9 and the 72. So 36 is a multiple of 9, and it's a factor of 72. So I can make my chain longer by adding something at the beginning, something at the end, but I can also add something in the middle. If I make a mistake, then it'll tell me. And I think I can put this back and then do that. So I get some feedback, and the challenge for everybody would be, can they make a very long chain? Getting a chain of more than 50 numbers is good. Getting a chain of more than 60 numbers is really good. Some people have managed to make chains of more than 70 numbers. So that's as good as it gets. If you can, okay, so
if you can get a number, if you can get a chain in the 70s or even 80s, do please let us know.
80s is going to be impossible.
You think 80s
because there are
impossible?
too many prime numbers
Okay, right, yeah.
larger than 50 that are going to get you stuck.
Do we have a current top number?
I think it might be 76 as the
Okay.
longest chain, and we're reasonably convinced that it can't be improved on.
Yeah, but if you can, let us know.
Okay, so I'm going to finish by going, so all our problems have an ID, NRICH.maths.org, and we've set up a page for you, NRICH.maths.org/CF for Cambridge Festival and 2022, because that's our year. So CF 2022. Earlier, we worked with 9 to 11-year-olds, and we worked on these problems. Just now, you've seen Claire and me working on Fruity Totals, Charlie's Delightful Machine, and we've introduced Factors and Multiples game. We haven't talked about the number jumbler, but that doesn't need explaining. If you go to the number jumbler, you might be surprised by what you see. And the challenge is for you to see where you can work out what is going on. The computer seems to be able to guess, predict what it is that you've been looking at, what icon it is.
Are you still with us, Charlie?
This. And then you might want to challenge friends or family to do something similar. We've also put links to a few other resources which are in a similar style. I think I'm going to stop there. It's just gone 1:45, and I think Liz is going to finish off talking about evaluation forms and things of that sort. Is this right, Liz?
I'm very happy to finish off. Thank you very much, Claire and Charlie. And thank you all at home for participating in the chat. I've just posted a link to the evaluation form. We'd very much appreciate it if you could fill it in, please, so that we can continue to improve our sessions. I think that's all that we need to say. We hope you've enjoyed working mathematically with us today. Enjoy any of the other festival sessions that you go to, and have a good rest of your Saturday. Thank you very much indeed. Goodbye.
Yep, thank you very much.
Bye-bye.
Bye.